All right, guys. So today we're doing 3.5E solving rational equations. It's a three-part situation. So part one is going over adding and subtracting, because when you're solving, you may need to add and subtract, right? Part two is going to be going over what's called complex fractions. And so complex rationals. And so we'll be looking at those. And then part three is ultimately the solving. Okay. So we're going to go through this again as we're going through it. Ask questions, stop. I will probably leave some of the problems for you to practice, to try. It's just that due to time constraint, we will not be able to practice and try as much in class as we normally do. Okay. Because I want to make sure we get through the gist of it so that you have all the general information to do the problem. Okay. So starting off, we're going to start off with part one. Part one is adding and subtracting. So when you're adding and subtracting, just like any other fraction, they need to have a what? Common denominators, right? In order to add and subtract fractions, they have to have a common denominator, okay? At this point, guys, you don't need computers. You should be paying attention. You should be taking your notes. You don't need any devices, okay? So when we're doing this, the first thing we want to do is factor the denominator. The reason why we want to factor the denominator is to see if, figure out what is our LCD. Remember, LCD is your least common denominator. So very similar to least common multiple, it's just your least common denominator. That's all it is. So what is the smallest number, well, number or variable that I can multiply both fractions by so that they can have one denominator, okay? So then we're going to multiply each term to get the denominator, LCD. And then remember, what you do to the bottom, you have to do to the top. Because the goal is that you're just creating a one in disguise, right? We're not trying to change the value of the problem. We're just trying to change how it looks. Does it make sense? You're not changing the value, just how it looks, okay? Then we're going to add and subtract to combine like terms. We're going to simplify more if possible, and you're going to simplify each sum or difference, and then state any restrictions on the variables. So state anything that would make our x's, our denominators at any point equal to 0, okay? All right, so we're going to start here with the first one. So example number one is where our denominators are already factored, right? There's nothing else I can do. They're both fully factored, okay? Step one says we're going to factor the denominators. Check. Step one's done. Step two says to find your LCD. So for this problem, our LCD is just going to be both factors of the denominator because they have nothing in common. So it's just going to be x minus 1 times 2x plus 1. Okay, so that's what step two is telling you, to find your LCD. Step three, it says to multiply each term to get the denominator. So when you're looking at the first fraction, you're asking, well, I already have x minus 1, but I don't have 2x plus 1. Does that make sense? So I'm going to be multiplying the first fraction times 2x plus 1 over 2x plus 1. Okay? I'm going to write it bigger and better in a second, but that's what it's saying. Then you're asking yourself, what is the second fraction missing in order for it to have a common denominator? X minus 1. So I'm going to multiply the top and bottom by x minus 1 times x minus 1. Okay? What this allows for you to do is to be able to combine the fractions by giving them one common denominator. So now our common denominator is x minus 1 and 2x plus 1. In our numerator, we have 2x plus 1 times x plus 2 plus this side, we have x minus 3 times x minus 1. And now instead of two fractions, we have one. So at this point, you're going to multiply and combine like terms, right? So we're going to just FOIL our little selves away. So when I FOIL, 2x times x is going to give me 2x squared. Then I have 2x times 2 gives me 4x. Then we have 1 times x gives me. And then we have 1 times 2 gives us 2. Okay, we're gonna do the same thing on the other side. X times X gives us. X times -1 gives us. -3 times X gives us. And then -3 times -1 gives us a +3.
No, we just combine.
So we'll combine, and we're gonna now multiply the denominator. So we have X times 2X is. We have X times 1 is. -1 times 2X is. And then -1 times 1 is. -1. So we've now completed step 3. We've multiplied everything out. Step 4 says we're going to do what? Now it's time to combine like terms. Add and combine like terms, right? So now we're on step 4 of adding and combining like terms. So I have 2x squared and 1x squared. What is that going to make? 3x squared. I have 4x, 1x, -1x, and -3x. 4 plus 1 is 5. 5 minus 1 is 4. 4 minus 3 is 1. So it becomes plus 1x. And then last are my constants. So we have 2 and 3, which makes 5. Now we're going to do the denominator. The denominator, 2x squared, has no friend. But we have 1x and -2x. What does that make? -x and then -1. So your sum is this. Okay. Now it says to simplify more if possible. When it says to simplify more if possible, that means I'm going to check to make sure that nothing can be factored and eliminated. Okay. So when it's telling me to simplify more if possible, I'm just going to do a quick factor check. If I did 3 times 5, my A times my C, that's 15, right? Is there anything that's going to multiply to give me 15 but add to give me 1? No. So can I factor that? No, it's not going to come out to be a factor of a small or reasonable number. It's going to eliminate. Does that make sense? Okay. So simplify each sum or difference. I've already simplified. I can't go any further. Simplifying's done. The last part is to state any restrictions on your variables. Okay. Your restrictions for your domain go back to your original for the most part. So you're going to check the denominators, your LCD, which was your least common denominator, right? So when I'm looking at my restrictions for adding and subtracting, I'm going to look at the LCD. So looking at my LCD, what are the restrictions that X cannot be? X can equal 1, and X cannot equal negative what? -1/2, because I would have to subtract the 1 and then do what? Divide the 2, because the goal is to get X by its self. So again, these are coming from the fact that I would have X minus 1 equals 0 and 2X plus 1 equals 0. And what do I have to do to get X by its self?
Oh, I get it now. You have to divide it.
Yes. Because it's your denominator. And our denominator can't equal what? 0. So when you're adding and subtracting, you're trying to find your domain restrictions, you're going to look at your LCD. Okay. So the first example we had was that they didn't have any common factors. The next example we're going to look at is that, they're going to have a common factor. So example number 2, we have X divided by X squared minus X plus 1 over X. Step 1 says to make sure that your denominators are factored. So this one's good to go, right? I'm not going to touch it, but is this fully factored? No. This can be factored by using your greatest common factor, and the GCF here is X. So when I factor out X, I'm left with X times X minus 1, right? Do we all see that? So now I can state the LCD. So your LCD is first, what do they already have in common? X. And then what do they not have in common? x minus 1. So this is your least common denominator. So looking at the first fraction, it already has our LCD, right? But looking at the second fraction, does it look like our LCD? No. What is it missing? X minus 1. So I'm going to have to multiply the top and the bottom by x minus 1. And again, this is just 1 in disguise, right? Anything divided by itself is 1. So now I can write it as one fraction. So we have x plus 1 times x minus 1 all over our least common denominator, which is x times x minus 1. The goal of an LCD is to get from 2 fractions to 1, okay? To get from 2 to 1. So now we can go through and multiply. So we multiply. Now we're going to distribute and keep it pushing. So we end up with x, distribute the 1, which just makes it plus x minus 1 all over x squared minus x. Combine like terms. Our like terms are x and x, which makes 2x. It becomes x squared when you multiply, but when you're adding, it becomes 2x. All over x squared minus x. There's nothing I can simplify. There's nothing they have in common. So this is my sum. Okay. I go back to my LCD to find my restriction, right? So step 7 is to find your restrictions. What are the restrictions on my x's? X cannot equal 1, and what else? 0, and x cannot equal 0.
Oh, yeah, that makes sense.
Because if I plug in 0, it's going to make everything 0, right? If I plug in 1, then it makes this 0. X cannot equal 0. X is a single factor here. It's a monomial. So that means if x was to equal 0, it would make everything else around it 0. It annihilates everything else.
So that one with that.
Okay. Our last example is when one fraction does not have a denominator. Well, what do? You put it over 1. When you don't have a denominator, it's Casper the Friendly One pops out. And now does it have a denominator? Yes, it does. Okay. When that happens, your LCD is just going to be the only denominator that's present. And the only denominator that's present is y squared plus 3y. Okay, so this fraction is missing y squared plus 3y, which means that I'm going to have to multiply the numerator times y squared plus 3y. Does that make sense? So we end up with 4y times y squared plus 3y. This one, I don't need to touch, right? The LCD is the denominator, so it's just going to be minus y plus 2. Notice that when a minus follows, I put a parenthesis, okay? The reason why you have to put that parenthesis is because when you're subtracting polynomials, the subtraction applies to every term, right? Not just the first term, but every single term. So when you're subtracting polynomials, make sure, and our denominator is y squared plus 3y. So now we're just going to distribute and combine. 4y times y squared is y cubed to the third power, right? 4y times 3y is going to give us 12y squared. Now we're going to distribute. Negative times positive is a negative y. And a negative times positive is going to make it a negative 2. And this is all over y squared plus 3y. Factoring this will not help. It will not eliminate. It will not get rid of anything. So guess what? This is your difference.
How do we know when factoring is
So you can, if you look at your factoring techniques and start factoring out mentally, it's probably the best way to think about it. So mentally, I look at this, I'm like, oh, this would be a grouping, right? I would group you, and I would group you, and I would group you, right? When I start grouping though, this is gonna factor out to become 4y, y plus 3. When I group this one, it's gonna factor out to be y plus 2. Can I do anything further past that? No, because your binomials have to be the same. And my binomials would not be the same, so therefore, the factoring is not factorable.
Can x ever equal 0?
Yes.
So if you have a negative x and the x happens to be 0.
It's still 0.
Negative 0?
I mean, it's just 0. It cancels it out.
I'm not going back to negative 0.
Yeah.
I just thought, like, it can actually happen.
If you have
0 is
negative x,
neutral, so it can't be positive nor negative.
0.
But what if it's negative x? If the x is 0.
Well, your x cannot equal 0 percent in the denominator, so 0 is going to cancel out anything. Yeah. It's kind of like a bomb in a fraction. Okay.
I thought I was on this one.
All right, so when I look at this, it's not going to get me any further, so then there's no need to factor. All right, last but not least is to state your restriction. To state your restriction, you go back to your LCD, right? Right now, my LCD is not factored because we didn't do step 1 and fully factor. But if I was to factor this, I would take out y, and I'm left with y plus 3. So what are my restrictions on my domain? Y cannot equal negative 3 and y cannot equal 0.
Oh yeah, because
It's a y factor by itself. If I plugged in negative 3, boom, it'll blow up my denominator. If I plug in 0, boom, it'll blow up my denominator. Okay. All right, so that's part 1. I wish we could. All right, next, part 2 of 3.5E is called complex fractions. What is a complex fraction? A complex fraction is a fraction or fractions within a fraction. That's what it is. It complicates things, right? So you end up with a fraction within a fraction or fractions within a fraction. And what that means, basically, you want to simplify your numerator down to one single fraction. And again, that's by using LCD rules. And we're going to learn a little shortcut when they're small. And then we're going to simplify the denominator down to a single fraction. And then after that, it becomes to divide, which is keep, change, flip, right? Multiplying by the reciprocal, okay? And then you simplify, eliminate if possible, and then state any restrictions on the variables, okay? All right, stating restrictions on the variables is going to be very important for this one because, again, you have multiple fractions that you're dealing with, okay? So a good thing to start off with is to acknowledge your fractions in the very beginning also. So if you look right here, we have 1 over x plus 3 and 5 over y plus 4. So based on what we have right here, we can already say what x and y can't be currently, right? Yes? Does that make sense? Because if they're in the denominator, what's going to happen? It doesn't work. So looking at what we have right now, what can x currently not be? 0. X currently can't be 0 and y can't currently be 0. Does that make sense?
Yes.
Because if I plugged in 0 to either one of these, it would blow up my problem, right? It would be undefined. Okay. All right. We're going to learn a little shortcut to finding an LCD. Well, not an LCD, but a common denominator. Okay. So we're going to start with our numerator. So for our numerator, we have 1 over x plus 3 over 1. Because we talked about if there is no denominator, who's there? 1. Casper the friendly 1. All right. I like to call this chopsticks in a bowl. Okay. My teacher called it bats and ball, but I thought that was dumb. So, or bats in a bag or whatever she called it. Anyway, I call it chopsticks in a bowl because it looks like chopsticks to me in a bowl. All right. So 1 times 1 is 1. Your rice is your operation plus X times 3 is 3x all in the bowl. X times 1 is X.
I think it looks like a baseball bat.
It looks like chopsticks in a bowl.
There you go, 5.
Left to right, you cross multiply left to right. Mhm. So 1 times 1 plus X times 3
Where's there?
because it was 1 over X. And then X times 1 is,
Oh, it's after you do the.
you multiply the denominators. Okay, this trick works anytime. So if you had 1/2 plus 1/4, it does the same thing. 1 times 4 is 4 plus 2 times 1 is 2, all in a bowl, over 8, which gives you 6 over 8, which equals 3 over 4. Okay, if you want to be bats in a bag person, go for it. But I see chopsticks in a bowl, so I'm going to keep saying chopsticks. All right, we're going to do the same thing to our denominator, okay? So our denominator, we have 5 over y plus 4 over 1. 5 times 1 is 5. My rice is positive. Y times 4 is 4y over y. Okay, now what happens is this is your numerator, this is your denominator. So I'm going to rewrite it just so you can see it all together. But so the problem now, this equals 1 plus 3x over x all over 5 plus 4y over y. And now this is where you keep, change, and flip. But once you already have it separated, I like to remember keep, change, flip from here, because this is saying this divided by that, right? So we're going to keep, change, and flip. So we have 1 plus 3x over x times y over 5 plus 4y. And when you multiply, you just multiply straight across, right? If you're not good at multiplying, distributing out like just normally, you can write it all out. So we have y times 1 plus 3x over x times 5 plus 4y. So my final quotient is distribute. We get y plus 3xy all over distribute, 5x plus 4xy. And that is your quotient. Okay, from here, we also realize that there's another restriction on our domain. And that's right here. We already know x can't equal 0, but what happens to this guy?
Wait, where's the 9?
5 plus 4y.
Oh.
So y cannot also equal negative 4 over 5. It's a y. It's 5 plus 4y. Mhm. So remember, when you're looking at your denominators, you're saying what would make my denominator equal to 0, right? Well, we already know we can't be x. That was one of the first things we stated, right? But now we're down to 5 plus 4y. So if I have 5 plus 4y equal to 0, what do I need to do to get y by itself? We would have to, I wrote it upside down. You saw nothing.
I was gonna say, I said 5 over 4.
Yeah, I was like, wait, I wrote that upside down. There we go. I would have to subtract the 5 and divide by the 4.
Yeah.
Okay, so this is an example of the biggest it would get. For the most part. Yeah, this would be the biggest it would get.
That's a lot to remember.
Just remember, one denominator and the numerator, one denominator and denominator, keep, change, flip. One, keep, change, flip.
But then there's extra steps, to do, like, oh, but this one's different when we do this here, and like, then I forget that later.
I see it. All right, so again here, this is a easier one. Because your numerator is just a whole number, right? I don't need to do anything to it. It's good to go. It's done. But my denominator is not. So looking at our current denominator, what is our restriction that we already have? X cannot equal 0.
We have to do rice in the bowl.
Yes. Yes.
Well, there's also rice in the bowl. There's also rice.
There's also rice. Okay, or bats in a bag, however you want to do it, but
That's bad. Sounds good.
all right, here we go. Chopsticks in a bowl sounds great to me. 5 times 1 is 5 plus X times Y is XY all over.
Oh, man.
X.
Cancel out the X or not like
You
that.
cannot cancel out the X. Remember, you cannot cancel out across addition and subtraction. Okay, so the problem is we have -3 over 1. We're going to keep, change, and flip, right? -3 over 1. We're going to change the multiplication, and we're flipping this guy, right? This is what we're flipping. So we have X over 5 plus XY.
That means the y equals 0, because if it's 0, you multiply to x.
Yes and no. We're going to talk about it in a second. Well, good question. All right, so we have -3x over 5 plus XY. That's a weird looking plus sign right there. All right, so now we're down. This is our quotient. And Z brought up a good question. So does that mean y cannot equal 0? Right? Now, if X or Y equaled 0, would it affect the 5? It wouldn't. Because I would still have the 5 standing. Does that make sense? So whether X and Y are 0, it doesn't affect this because 5 would still be standing. Does that make sense? Yeah. Okay. So that's why Y doesn't have any restriction because it wouldn't have any impact on it. Okay. There would be only very specific times. So like if you were to kind of think about this and point it out, if you had I don't think I'll ask you this in depth. But if it said if X equals, exactly. So if you just have to know that X times Y cannot equal -5. So it's more of a combination of so X times Y cannot equal -5. Does that make sense?
Yeah.
Because it wouldn't necessarily be 0 that would be the problem. It would be if they equaled -5.
So you have like one of them was half and then it was negative.
Exactly. Any combination of, yeah, would be the problem.
We done?
Okay. All right. The last one is as easy as it gets. So the last one is showing you what it looks like if it's already one fraction in the numerator and one fraction in the denominator. What do you have to do? Keep, change, flip. There's nothing else you would have to do. So this would be a level 1 complex fraction. Everything is done for you. You just have to keep, change, and flip. Before you do that, state your domain restrictions. What can X not equal here?
0.
-2.
-2 and +1. Because if I plug in -2, it makes the numerator 0. If I plug in 1, it makes the denominator 0. Do we see that?
Wait, what's the numerator and what's the denominator?
So your numerator fraction is here.
So they're all numerator except for the bottom one?
Yeah, so you have a numerator fraction and a denominator fraction. That's what makes it complex.
So 3 is the denominator.
The 3 is part of your denominator. Yeah. So we have 4 over X plus 2. We keep, We're gonna change from division to multiplication, and we're gonna flip, and it becomes x minus 1 over 3. And now it's just straight multiplication. 4 times x minus 1 over 3 times x plus 2. And what do we get?
4x minus 4 and 3x plus 6.
And we get 3x plus 6. And that -2 already satisfies that restriction. Does that make sense? So that would be the simple one. All right, that is complex. I know. All right, here's 3.5E, part 3, solving rational equations, okay? So when one or both sides of a rational equation has a sum or a difference, you're gonna make sure you multiply each side of the equation by the LCD to eliminate the fractions. The goal is to basically not have to work with fractions, but to turn it into a linear or quadratic or something that you're familiar solving. So first thing you want to do is find the LCD of all the denominators. You may need to factor. You want to multiply all terms by the LCD, divide and simplify, and then use inverse operations to set one side equal to 0, factor if possible, zero product property, meaning that if you set each product equal to 0 and solve for x, then there's your solution. And then check your solutions by plugging it back into the original rational equation. So first example we have here is 6 over x plus x over 2 equals 4. Step 1 is for me to identify my LCD. So my LCD for this problem is, what is my common denominator? It would just be 2x, right? So my LCD would be 2x. That means I'm going to multiply each numerator by what the denominator is missing, okay? So that it's all over one fraction. And the reason why we want it all over one fraction is because once your denominators are the same, all you're doing is solving the numerators, okay? So when I look here at 6 over x, x is missing 2. So that means I'm going to have to multiply the numerator and denominator by 2, okay? When we look here, we're going to look at the denominator. The denominator is missing an x. So I'm going to multiply the numerator and the denominator by x. When I look at the 4 denominator is technically a 1. Ask for the friendly 1. So in order for it to have the LCD, I'm going to have to multiply the numerator and denominator by 2x. Is what we're doing. So when it's all said and done, I'm going to end up with 2 times 6 plus x times x equals 4 times 2x. And all of that would be over the same denominator. Because once they all have the same denominator, all you have to do is worry about your numerator. So the denominator is now irrelevant, and you're just going to solve from here. So we end up with 2 times 6 is going to give us 12. X times x is x squared. 4 times 2x gives us 8x, okay? So we multiply all terms by the LCD. There was nothing to divide and simplify. Well, we're going to divide, simplify if need to, but we're now at the simplify. We're going to use, there's nothing to divide and simplify. We're now at the inverse operations because we want to get one side equal to 0. So we're going to subtract 8x. When I subtract it, it has nothing to combine with on the other side. So we're just left with, I'm going to write it in decreasing order of power. So x squared minus 8x plus 12 equals 0. Now this is just a quadratic, a simple quadratic at that. So I'm just going to factor it. So I'm asking myself what multiplies to give me 12, what adds to give me -8. And that would be x minus 6 and x minus 2. That's because -6 plus -2 is -8, and -6 times -2 is +12. Okay, so from there, I can now say that x equals 6 and x equals 2 are my two possible solutions. Okay, so the last step is saying to check your solutions in original rational. So I'm going to go back to the original and plug in the values and see what happens. So I'm going to check 6 first. So checking with x equals 6. That's going to look like this. So we have 6 over 6 plus 6 over 2, and we want to know, does it equal 4? 6 over 6 is 1. 6 over 2 is 3. Does 3 equal 4? And the answer is yes. So x equals 6 is a possible answer. We're going to do the same thing with x equals 2. We're going to plug it in for x. So we have 6 over 2 plus 2 over 2. Let me get some of that extra out. 2 over 2. And we want to know, does it equal 4? We get 6 over 2 is 3. Plus 2 over 2 is 1. And that equals 4. So we know our two answers are x equals 6 and x equal 2. Okay. All right. So here are some further examples. If you would like, I would like for you to pause right now, and then you can try this one on your own and see how it goes. All right, you're back. So let's see what happens now. So here we have 2 over x plus 1 over x. So the LCD for this problem is just going to be x, right? So that means that these two can be combined already. But this side, remember, it's 3 over 1. I'm going to multiply the top and the bottom by x. So we're now working with 2 plus 1 over x equals 3x over x. So your denominators are the same. So denominator doesn't matter. All you have to do is worry about the numerator. Okay? So 2 plus 1 is 3 equals 3x. So therefore, to get x by itself, we would divide by 3. And so x equals 1. Okay, I'm going to check to make sure this works out. So going back to the original, if I let x equals 1, I have 2 over 1 plus 1 over 1. Does it equal 3? And it does. So I know that x equals 1 is my answer. All right, this one's a little more complex. So here we actually have, we haven't really brought up difference of cubes in a while, but this is a difference of 2 cubes. So we have a difference of 2 cubes here. How do I know they're cubed? Because x to the third and then 27 is 3 to the third. So we have difference of 2 cubes. So it's going to be helpful to fully factor so that we can figure out what our LCD is. So we have 1 over x minus 3 equals x minus 4. Remember, when you're doing difference of cubes, you're taking the cube root. So we end up with x minus 3. That's our first factor. But then our second is actually going to be x cubed. Hold on. My thing is doing something weird. Okay, so we left off with the difference of cubes. I have no clue why I wrote square there. So when you're finding a difference of cubes, it is going to be x minus 3. Let me write it out, the rules at the bottom, just to remind you. So sum and difference of cubes. If I have a cube, it's a weird looking thing. A cube minus b cubed, it equals the binomial a minus b, which is just the cube root of your a term and the cube root of your b term, times a squared. It's going to always be the opposite. So if it's minus here, then it's going to be plus here, plus a times b, and it's always positive at the end, b squared. Okay. And then if you have a cubed plus b cubed, it equals, again, always the opposite on the binomial, meant the same on the binomial, opposite on the first term of the trinomial, a plus b times a squared minus a times b plus b squared. Okay, so those are going to be our rules that we follow. All right, so here we have x minus 3. Cube root of x cubed is x. Cube root of 27 is 3. So it's going to give us x squared plus x times 3 is 3x plus 3 squared is going to give us 9. So those are our factors. All right, so then after we identify our factors, we want to look at our LCD. Well, our LCD is this. That's going to be the least common denominator. So this denominator is missing the trinomial x cubed plus 3x plus 9. So what that means is I'm going to have to multiply 1 times x cubed plus 3x plus 9. So I'm multiplying 1 times x squared plus 3x plus 9. Okay. Now, once I multiply 1 and also your denominator, the denominator no longer matters because the denominators are going to be the same. So all I have to do is focus on the numerator. So we have x squared plus 3x plus 9 equals x minus 4. Okay. After this, we want to get one side equal to 0. So I'm going to subtract x and add 4. Subtracting x and adding 4. Okay, that's going to give me x squared plus 2x plus 13 equals 0. Okay, so it's asking you, now we're down to solving this out. So on this one right here, this isn't going to be an easy, pretty factorable situation. So what ends up happening here, we're going to have to use a quadratic formula. Okay, sorry. So we're going to use the quadratic formula. So remembering the quadratic formula. So in order to do the quadratic formula, you're going to need an extra piece of paper because we don't have enough room in this space to do it. So I'm just going to create my little extra piece of paper by covering this bad boy up. But remembering the quadratic formula, so your quadratic formula, that's where we have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? So your a, that's your a, your leading coefficient. So a, your b, and your c. So when you're plugging into the quadratic, we end up with x equals negative 2 plus or minus the square root of 2 squared minus 4 ac divided by 2a. So we're going to do some math here. So we have negative 2 plus or minus the square root of 4 minus, and 13 times 4 is going to give us 52 all over 2. So this equals negative 2 plus or minus the square root. 4 minus 52 gives us negative 48 over 2. Okay, we've talked about this before. Oh no, we have a negative. So that means that there is no real solution for this. It's going to be an imaginary solution. In order for this to be true, it would have to be an imaginary solution. And so when we have the square root of negative 48, remember 48 can be broke down to 16 times 3, right? So this is the same thing as taking out the I. And then we would have square root of 16 times the square root of 3, right? So we have the square root of 16 times square root of 3. So this equals negative 2 plus or minus square root of 16 is 4. We have our I because it's negative square root of 3 over 2. And this is what our x would be. Our approximate value of x would be this guy, the imaginary, okay? So it doesn't give us a real. We end up with an imaginary. All right, we're going to do the last one. So on the last one over here, we have 6 over x minus 1 plus 2x over x minus 2, right? So for this one, our LCD is actually going to be, so the LCD here is actually x minus 1 times x minus 2. It's going to be both of the denominators multiplied together because they have no common factors already. So I'm going to have to multiply by what they're missing. So x minus 1 is missing x minus 2. So I'm multiplying the top and the bottom by x minus 2. X minus 2 is missing x minus 1. So I'm multiplying the top and bottom by x minus 1. Okay. And altogether, this is over 1. So this is missing x minus 1 and x minus 2. So I'm multiplying altogether x minus 1, x minus 2 to the entire numerator here. What's that going to happen? What's the purpose? Is so that we can eliminate our denominators. We don't have to worry about them now because we found what would be missing to make them equal. So what this would look like in terms of putting it all together, I would have 6x minus 2 plus 2x times x minus 1 all over x minus 1 times x minus 2 equals 2 times x minus 1, x minus 2, all over x minus 1, x minus 2, which is why now our denominators are the same, which is why all we have to do is focus on the numerators. Okay, so our numerators are going to distribute and combine like terms and then proceed to solve. So here on the first one, I'm going to distribute 6. I'm going to distribute the 2x. I'm going to FOIL and then distribute the 2, however I want to do it on that side as well. So we end up with 6x minus 12 plus 2x squared minus 2x equals 2 times, and we have x squared minus 2x minus 1x. Let me see if I can write that a little tighter together. X squared minus 2x minus 1x plus 2.
I'm not gonna be here 8th period, so I was gonna get the number.
Okay, so now we're going to finish. We're going to combine like terms and finish it out. So over here, I'm going to distribute the 2. So I have 2x squared. This is going to be negative 2 and negative 1 makes negative 3. So I'm going to go ahead and write negative 6x plus 12 equals, and over here, I have 2x squared. And then 6x and negative 4x make positive 4x. 6x and negative 2x make 4x minus 12. So notice I have 2x squared on both sides, so it's going to cancel each other out. And then I'm going to combine like terms and get, in this case, it's just going to be x by itself. So I add 6x. And that gives me 10x minus 12 equals 12. I'm going to add 12. And I get 10x equals 24. Then I divide by 10. So then we end up with x equals 2.4. Okay, then I can go back, plug it in, test it out, make sure I did it right. I would suggest using your calculator to check it and going there. Okay, on the back. All right, on the back, you have these problems. And the goal for the back here is I just want to make sure that you understand how to combine them. And if you're not comfortable with finding a greatest common factor, a least common denominator, this is a good time for you to practice. So again, you want to make sure everything's fully factored. I'm going to use GCF to factor out 3, and it's going to give me x minus 4. So when I factor that out, I can see that the LCD is going to be 3x minus 4. So this is my LCD. 3 times x minus 4. So that means in order for me to only have to worry about the numerator, I need for everyone to be over 3 times x minus 4. So this fraction, the first fraction, it's not missing anything. It has 3, it has x minus 4, it's good to go. The second fraction in the denominator, it needs a 3. What I do to the bottom, I have to do to the top. The last fraction here, it has 3, but it doesn't have x minus 4. So it needs x minus 4. What you do to the bottom, you're going to do to the top. And now you're going to multiply your little cells out. So we have 7 minus 3 all over 3 times x minus 4 on the left side equals 2 times x minus 4 all over 3 times x minus 4. And now my denominators are the same. So in order to solve, I just have to worry about the numerator. So 7 minus 3 is 4. So we get 4 equals 2 times x minus 4. A lot of times you guys want to distribute first, but when it's something you can see that can be easily divided, you might as well just divide. So I can easily divide by 2 here. And that's going to give me 2 equals x minus 4. I'm going to add 4. And I end up with x equals 6. So the solution here would be x equals. All right, so we're going to continue 3.5E, part 3 of solving rational equations, which we were talking about solving rational equations. So we're going to do this by hand, and then we're going to use the calculator to check and show why it's super important that you're checking your answers. Bless me. All right. So notice here how on each side we only have one fraction. So the beauty about this is that because there's only one fraction on each side, we actually can cross multiply. And so we're going to cross multiply 2x times 5x. So 2x times 5x equals, and we're going to cross multiply 5 times x squared minus 5x. Okay, so what I end up here with is 10x squared equals 5x squared minus 25x. Okay, we still want to apply zero property here, so we can solve this, which means that we need to get x by itself. So I'm going to subtract 5x squared and I'm going to add 25x. That's going to leave me with 5x squared plus 25x equals 0. Okay. In order to solve this, I need a factor, so I can use the zero property. So I'm going to factor. I'm going to factor out 5x, and I'm left with x plus 5 equals 0. Okay. So we are left with 5x equals 0 and x plus 5 equals 0. So we end up with that x can equal 0 and x can equal -5. Okay. Now, this is an example of why it's really important that you go back and check your possible solutions. Okay, if we keep in mind also our domain restriction, so when I come back to this original problem, I know that x cannot equal 0. So that represents the fact that this is what we call an extraneous solution. So this isn't my real solution. My real solution is -5. Okay, x equals 0 is extraneous. It comes out mathematically when I'm solving, but when I plug it back into the original, it will not work because in the original, x cannot equal 0. Okay, so next we're going to use a calculator and show you how to solve this in a calculator. So notice on my right-hand side, on my left-hand side, I have 2x. So I'm going to protect my numerator. 2x divided by 5 is just a number. And then I'm going to do on the right-hand side, I'm going to put in y2. So protect my numerator, x squared minus 5x divided by, parentheses, protecting my denominator, 5x, because it's not just a number. And what I'm going to do is I'm going to graph and see what happens. So, oh, thank you. So notice it graphs the first function, then it graphs the second function. Please ignore that bell. So when it graphs, I can clearly see that they intersect at one point. Notice how at x equals 0, they do not intersect. So that's another example of why this is an extraneous solution. I can also click second graph and go to the table to see if I can find that point of intersection. If you look here at 0, one of the functions is defined at 0, but the other one has an error. Remember, it has that removable discontinuity of there being a hole at 0. But I go up to where it was looking like they were intersecting, and notice at -5, I get -2 and -2. So that is why -5 is my real solution. We're going to go back to the graph. From the graph, you also can find the point of intersection by pressing second, trace, and intersect. You want to use your little spider to crawl as close as possible to the intersection, the point of intersection. Once you're close to that point of intersection, you're going to hit enter 3 times. 1, 2, 3. And I hit enter and it says -5. So when x equals -5, both equations equal -2. Okay, so that's another way of using the calculator to help us prove our point. All right. So now looking at the last one, again, we can set up using multiplication, so we can cross multiply. And we end up with 8 times x minus 1 times x minus 2 equals 4 times x squared minus 4. Okay, being mindful of what we have here, we know that what x cannot equal. We know that x cannot equal +2, and we know that x cannot equal -2 based on our denominators, difference of 2 squares, and that factor is already done. All right, so we're going to go forth and multiply. So I'm going to distribute, and I get 8 times x squared minus 2x minus 1x plus 2 equals 4x squared minus 16. Okay, I'm gonna distribute the 8. So I get 8x squared, a -2, and a -1 makes -3. -3 times 8 makes -24x. Plus 16 equals 4x squared minus 16. Now I'm going to combine like terms. So by combining like terms, I'm going to subtract 4x squared and add 16. So when I do that, I'm going to be left with 4x squared minus 24x plus 32 equals 0. Okay, so before I do anything, I can factor out 4. I can find a GCF of 4. So I can divide everything by 4 because that's my greatest common factor. That's going to give me 4x squared minus 6x plus 8 equals 0. So I'm asking myself what multiplies to give me 8, but adds to give me -6. So my factors would be x minus 4 times x minus 2 equals 0. And we don't forget to bring down our GCF. So my two possible solutions are x equals 4 and x equals 2. Now, what did we say about 2's in the beginning? These are our restrictions, right? X cannot equal 2 and x cannot equal -2. So therefore, x equals 4 is our real solution and x equals 2 is an extraneous solution. Okay, so we got to be mindful of this when we are working, and that's also why it's super important for you to check and plug in. Could you have used a calculator and found the intersection by using y1 and y2? Why, yes, you can. Just make sure when you're plugging into the calculator that you're protecting your numerators, protecting your denominators. Okay, otherwise your graph will be messed up. All right, that concludes 3.5E, which concludes unit 3.5. Please prepare for your test.